Hello and welcome to my explanation for acceleration. We are going to look at what acceleration is, and we are going to look at how to solve a typical exam question without really having to use a formula at all. So what is acceleration? Acceleration means when something gets faster or when something slows down. Here's a car. At 0 seconds, it's stationary, it's just sitting there. If it's accelerating, then after 1 second, it will have moved somewhere. After 2 seconds, it will obviously continue to move, but it will get even further away because it's getting faster. After 3 seconds, where is it going to be? It's going to be even further away because it's getting even faster. And so in that same amount of time, in 1 second, it's going to have traveled even further. So let's look at this in words now. Acceleration means change in speed, either getting faster or getting slower. But what's the definition? What would you write down on an exam? You would write down acceleration is the rate of change of speed. This is the more formal scientific way to write acceleration. Now, what does rate mean? Because this sometimes confuses people. Rate just simply means divide by time. It means how much in a given time. So once you know this, you can actually figure out the formula if you needed it. If it said, for example, write down the formula. So all you need to remember is acceleration is the rate of change of speed. And then you can figure out acceleration means or is change in speed divided by time. So I'm going to show you the formula, even though we don't really even need the formula to solve a lot of exam questions. So we know that acceleration is the rate of change of speed, or we know that rate means divided by time. So acceleration is simply change in speed divided by time. On the right is the same formula in symbols, and you'll notice that sometimes we use this triangle to mean change, and we'll use V to represent speed. V standing for velocity, which is not the same as speed, but it's similar to speed. Sometimes you'll see it written as this. Instead of change in speed, you'll be given the final speed and the start speed. And obviously, if you subtract one from the other, then you get the change in speed. And here on the right is it in symbol form. Either of these formulas is fine. They're exactly the same. They mean the same thing. So again, to recap, acceleration means rate of change of speed. Now, what does this mean? It means that every second, speed is increasing. So every single second, the speed something is traveling gets higher. So we know that speed is measured in meters per second. So every second, the meters per second is increasing, is getting higher. So this gives us the units for acceleration. Now, probably most people can say this straight away. Acceleration has units of meters per second squared, m/s squared. What does this actually mean? Well, it's sometimes more useful to write it as this. Meters per second squared means meters per second, which really means meters per second, or meters per second every second. So what this is saying here is every second, the meters per second is increasing. Every second, the speed is increasing. So this is why this is acceleration, and it's simplified to this. At GCSE, you could actually write this. This is slightly better, but this is absolutely fine at GCSE. Every second, the speed in meters per second increases. So let's now solve an exam question. So at the start of a race, a person accelerates from a velocity of 0 meters per second to a velocity of 8 meters per second in 4 seconds. Calculate the acceleration of the person. So you might know the formula, you might be able to plug the numbers into the formula straight away, but if you don't know the formula or you're a bit unsure, how can you solve this? Well, let's think about this. Supposing we draw a number line. Supposing we say that we're going to label this number line with the information in the question. So the starting speed goes on the left-hand side, that's 0 meters per second. They accelerate from 0 meters per second to 8 meters per second. So the final speed, the final velocity is 8 meters per second. And they do this in 4 seconds. So every second, how much faster are they getting? Well, we need to go from 0 to 8, sorry, in 4 seconds. So 0 to 8 in 4 steps. How do we go from 0 to 8 in 4 steps? Well, in one step, we'd obviously go 2. In the second step, we'll go another 2, another 2, and another 2, and so on. So now what have we done? We've gone 2, 4, 6, 8 meters per second in 4 steps in 4 seconds. 1 second, 2 seconds, 3 seconds, 4 seconds. So this gives us our answer. The acceleration is 2 meters per second squared, or 2 meters per second every second. If this takes 4 seconds, then it's going to take 1 second, 2 seconds, 3 seconds, 4 seconds. So we get our answer of 2 meters per second, or 2 meters per second squared, without ever having to use a formula. Let's look at one more example. At the start of a race, a pigeon accelerates from a velocity of 0 meters per second at a rate of 3 meters per second squared for 5 seconds. Calculate the final velocity of the pigeon. So usually this would require you to write the formula, to rearrange it, to substitute the numbers in and solve it. Or we can solve it without ever having to use the equation, using a similar idea to the previous question. So let's draw a number line. Let's draw what we start at, 0 meters per second. Let's think, after 1 second, what will happen? Well, we're accelerating at a rate of 3 meters per second squared, which means 3 meters per second every second. So after 1 second, how fast will the pigeon be moving? 3 meters per second. After another second, how fast? 6. After another second, how fast? 9. Another second, 12. And finally, after 5 seconds, we're going to reach our final velocity of 50 meters per second. So every second, they get 3 meters per second faster, and we're going for 5 seconds in total. So our final answer is 15 meters per second. So we've solved probably a 3-mark exam question without ever having to use a formula. Here are 2 more questions for you to try. So pause the video now and try these 2 questions using the same method. So question 1A, the answer is 6 meters per second squared, and question 2A, the answer is 4.8 meters per second squared. You could solve these in either method. You could use a formula or you could use the number line. If you use the number line, super easy, no formula at all is required, which means you can get loads of marks in an exam by actually just thinking and using your common sense and your math skills. Finally, there's a tiny bit of additional information that's really useful to remember. Acceleration is a vector, which means it can be positive or negative. So you can have a positive acceleration, which means you get faster, or a negative acceleration, which means you get slower, sometimes known as deceleration. And finally, accelerations are caused by forces that are not equal. This links into the forces section of the course, but you only get an acceleration if the forces are unbalanced or different. If the forces are balanced, you will not get an acceleration.